Another one. 5 over 4x plus 5 over 3 over 20 equals 2 over x. These are a little different looking denominators, and so that's why I wanted to do this one with you. Notice here, no factoring denominators needed here. Nothing factors, so I'm just going to go straight to my LCD. Well, I've got an x. Do need an x here in my LCD. What else, though? Well, I also haven't done anything yet, have I, with the 4 and the 20? Yeah, 4 and 20, those are just regular numbers. They're not, involved in our binomial or anything like that. So those are just like regular numbers that I need to come up with a least common multiple of. And so this is, like the first problem we did where we had the 3 numbers. But yeah, so what multiple do both of those have? Well, 20 just so happens to be a multiple of 4. So I can say 20. How about 20? Yeah, 20 is a multiple of 4 and of 20, so let's go with 20 for it and put it in front of the x. So that's our LCD in this case, 20x. All right, so now what do we do with that? Well, we take that and multiply it by all 3 parts. $20x times all 3 parts. Okay, well, again, that being it's over 1. Of course, I can cancel the x's out. What about the 4 and the 5? Yeah, there's a common factor of 4. Cancel 4's out there, so I have 5. 5 times 5, 25. So I have 25 in the first slide. All right, then here, well, that's going to nicely go out, isn't it? 20s, cancel. X times 3, it's 3x. And then over here, where to get 3 over 20? That's 2 over x. Where 3 over 20 came from. All right. Yeah, what cancels on the right side there? Well, cancel the x's out. 2 times 20. That gives me a 40. Okay? All right, well, let's go with it here. We subtract the 25, don't we? Both sides. We get 3x equals 15. Divide by 3, and the x is going to equal 5. Check to see if that's excluded. 5 would not make that denominator 0, nor would it make that denominator 0, so no, it's not excluded. It is a good, solid answer there. 5 is your answer for that one. Okay? All right, well, let me give you another couple here. All right. 2 over 3t minus 6 plus t over 15 equals 3 over t minus 2. All right, we are going to have a little something different happen in this one. So that's why I want to show you this one. What happens in this one? Well, starts off about the same. Look at them, and you can see there is one denominator that can be factored, isn't there? First one right here. Yeah, we can factor the first denominator, so that's where I want to start. Start by factoring it. How does 3t minus 6 factor? Well, it has a common factor of 3. Take out a 3. That'll leave me t for that, minus 2 for that. Okay, so that's where we're going to start. The rest stay the same. All right. Now we go to LCD. LCD-wise, I see, well, I've got a t minus 2 factor, so I need it. And then, again, like on the previous one there, I've just got some regular numbers. I've got 3, I've got 15, so I need a common multiple of those. And again, just so happens 15 is a multiple of 3, so I can use 15 as the least common denominator for those. 15, t minus 2 is going to be my LCD. Take that and multiply it by all 3 parts. So we got 15 times t minus 2. No, I'm going to have to move over here a little bit. All right, 15 t minus 2 by all parts. 2 over 3 times t minus 2. 15t minus 2 times t over 15. And then 15t minus 2 times 3 over t minus 2. All right. Do some of the canceling here. The t minus 2's out. And then I've got, again, that's 15 over 1, so I can go 3 into the 15, can I? Reduce those by 3. 5 times 2 is what I've got. 10. Up front here. 15's cancel on the second part, so what do I have? Well, I have t times t minus 2. Or t minus 2 times t. All right, then over here, the t minus 2's cancel, so I have 15 times 3 is all that's left, which is 45. All right, just like before, I do need to distribute the t, so let's do that. What do I get there? T times t is t squared, and then t times minus 2 is minus 2t. Okay, well, yeah, here is why I do this one, because at this step, we get a little something a little different. And the something different we get is that this is a t squared equation. We now have a t squared equation. How do we solve t squared equations? Well, we solve this one by factoring. We're going to have to use factoring to solve that. And in using factoring, remember, to solve a factoring one like this, what do you need? You have to have one side be 0. So I'm going to have to make one side be 0 and then factor to solve this one. All right, well, obviously we're going to make the right side be 0. That's going to be minus 45, and that's going to go right here with the 10. So let's do that to make, yeah, I'm going to have the right side is 0 there. Now, the other point here is I'm not going to put the, that'll be minus 35 first, because you remember I want them in order, and I want to start off with the squared one, so I'm move the t squared up front here. Then I'm going to go with the minus 2t, and then put 10 minus 45, which is a minus a 35. Okay? Reorder those. Now I can do the factoring. Factor my trinomial. T squared, so that'd be t here, t there. Minus 35, minus 2 in the middle. 5 and 7 would work because, yeah, I can get minus 2 out of that if I do a positive 5 and a negative 7. All right. Now what? Well, then I set each individual factor up equal to 0. Here I would subtract 5, so that's going to give me t is negative 5. Here I would add 7, so that's going to give me t equals 7. Either one of those excluded, back at the original equations here. 2 would be excluded. Well, 2 would be excluded in both of those. So negative 5 is okay and 7 is okay. So we get 2 answers for our rational equation in this case, negative 5 and 7. Okay? All right. Now, I need to mention another technique for solving these rational expressions, rational expression equations. And that's this. Or that's used, let me show you here, first of all, where we'd use this other technique. It's those previous ones, we're not going to, of course, we'll use the LCD technique like we did, but for ones like this, look at this one. 4 over x equals 33 over 70. Okay, well, yeah, I bring this one up because, yeah, we can use what's known as cross-multiplying on such a one as this. Here's how that works. Yeah, notice this one's different because what I've got on the left is one single fraction, and then on the right I've got also one single fraction. The previous problems that we worked had, well, it had 2 on one side, more than 1 on one of the sides. Well, in this case, I've got one fraction on each side. So if I have one fraction each side of the equal sign, here's what you can use, what we call cross multiplication. Cross multiply. Here's what I mean by that. By cross multiplying, what I mean is take the top here times the bottom over there, 4 times 70. And it turns out that equals the other cross product, that is 33, the top over here, times the bottom on the left, 33 times x. That will always be true. Numerator on the left times denominator on the right equals vice versa. The numerator on the right times the denominator on the left. Crossing, multiplying. Okay? All right, well, that helps us, of course, here because now we can solve that. 4 times 70 is 280. 33 times x is 33x. That's just a simple, nice little equation. All you have to do, divide off 33. 280 divided by 33 does not simplify, I don't believe. We're done. It's not exclude a value. X is 0, be excluded. So 280 over 33, by all means, is not excluded. So that's our answer. Okay? All right. What about this one? 5 over p plus 2 equal 4 over p minus 7. Well, okay. Again, cross multiplying can be done here because, yeah, you've got one fraction equals another fraction. Anytime you have that, you can use this cross multiplying. All right, so let's see what happens here. I'll take the top times the bottom over there. So that'd be 5 times p minus 7. And notice I'm putting those in parentheses because guess why? Yeah, it's going to have to be distributed in the end here. All right, then do the same thing over here. Take the top times the bottom, so that'd be 4 times p plus 2. All right, well, that gives us a nice little equation. Distribute the 5, so we have 5p minus 35 equals then over here. That would be 4p plus 8. Yeah, all I have to do is subtract 4p both sides and add 35 both sides. So I have 5p minus 4p, that's 1p, 35s, 4p's go out, so that's 43 on the right. P is 43. It's not excluded. It's all good. Okay? All right, well, that can be done in those scenarios there. Now, let me show you one more. Something looks a little different. Let's say we've got 5 equals x plus 2 over 2 minus 3x. All right, well, one way you can go solve this is we can use cross multiply here as well. Just think 5, we could write it as a fraction, 5 over 1. Rewrite it like so. Yeah, think 5 over 1. And we cross multiply, can't we? You got one fraction equals another fraction. So we can do our cross multiply. Take the 5 times the 2 minus 3x. And then x plus 2 times 1 is just x plus 2. All right. So yeah, we can do cross multiplying on that. So that's that'll be 5 times 2 is 10. 5 times minus 3x is minus 15x equals x plus 2. Okay. On this one, I think I'll do this. Let's subtract x and subtract 10, both sides. I'll get rid of the 10s here. That'll be minus 16x. Get rid of the x's there, so that'll be minus 8. All I have to do then is divide by minus 16. And that reduces. Negative divided by negative is positive. The 8, there's a common factor of 8 there, so I can reduce those by 8. 1/2? 1/2. Okay. All right.